Not really. Okay. The most exciting thing, in my opinion, to do on Earth is to actually get away from it. And this doesn't mean that I'm depressed and, I want to just get away from Earth. It means that in my dream is to get into a rocket and blast off into space. And also that means, in my opinion, rockets have always seemed to be firing us into the future. Since the first modern liquid-fueled rocket soared into the sky in 1962, rockets have carried about 500 people and several thousand satellites onto the final frontier. While exploring space is obviously the main point of all that effort, it's worth remembering that stepping outside Earth gives us a better understanding of our own planet. Now, weather forecasting and climate research are some of the things that can be revolutionized by space exploration. Now, rockets are also useful things, but they're also very complex and highly dangerous. But how exactly do they work? Let's take a closer look. Now, the best way to figure out that out in the simplest way is to explain what a rocket is, what is a rocket composed of, the forces acting upon a rocket during its launch, and what powers a rocket. A space rocket is a vehicle with very powerful jet engines designed to carry people or equipment beyond the Earth and out into space. Now, if a space is a region outside Earth's atmosphere, that means there's no oxygen that can use to combust the engines. So one way to look at a rocket is this very special kind of jet-powered vehicle that carries its own oxygen supply. Now, a rocket needs great speed and huge amounts of energy to escape the pull of gravity. And to stop them from tumbling back down to Earth like stones, vast speed and energy means rockets have to generate enormous forces. Now that you know what it is, let's know what it's composed of. Now, a rocket is estimated to be composed of 3 million bits and pieces of all shapes and sizes. But it's simpler to think that it's made of 4 separate parts, which being, there's the structure, which is the framework that holds the whole thing together like the framework of a house, the propulsion system, which is the engine, the fuel tank, and any outer rocket booster systems, the guidance systems, the onboard computer-based navigation that steers the rocket to its destination, and the payload is whatever the rocket is carrying, from people to satellites to space parts or even a nuclear warhead. Now, the main function of a rocket is to escape the pull of Earth's gravity, as you might know, which means you have to create an upper force that is greater than the Earth's 9.1 meters per second squared force that Earth's gravity creates. Space is generally defined as starting at about 100 kilometers up in the air, or 60 miles above Earth, which is where conventional planes would struggle to make their own lift to stay in the air. You might think that space is a long way, but 100 kilometers isn't so far. For example, a car hurtling along a highway would reach there in about an hour, if it's going straight up, which means the rocket gets there about 20 times faster, which is just 3 minutes. Now, the force a rocket must create to reach space is called the escape velocity. Rockets burn huge amounts of fuel very quickly to reach escape velocity of at least 25,000 miles per hour, which is 70 miles per second, or 40,000 kilometers per hour, which is how fast something needs to go to break away from the pull of the Earth's gravity, which is escape velocity. Now, escape velocity suggests a rocket must be going that fast at launch or it won't escape Earth. Now, lastly, you need to add into account the other forces that come into play. Now, rockets are a great example of how forces act upon objects, or how things move. And it's a common mistake to think that rockets move forward by simply pushing the air. And it's easy to see this as a mistake when you remember that there is no air in space. Now, the force that pushes a rocket upward is called the thrust. But this also depends on how big the rocket is and how fast that the engine is spewing out gas. When a rocket's engine develops enough power, the thrust force pushing it forward will be bigger than its own weight, which is the force of gravity pulling it down. As the rocket climbs, air resistance or drag will try to pull it back down, fighting its own thrust. Now, that being my last point, now you know the basis of a rocket. Let's recap on the importance of rockets and space shuttles. Rockets shoot satellites in orbit to improve weather, navigation, military, and climate research. They send probes and rovers into other planets to find new homes for humans and to find other living life. And they will soon carry brave pioneers into the vast, never-ending expansion of space. And finally, whether it be a small advancement in the aerospace industry or groundbreaking discovery, space exploration will always be a giant leap for mankind.
All right, Jake. I like the visualization you have at the beginning with the rocket, and the language isn't in it is really nice. There's some good imagery that's going on there. I just wish that you weren't reading it. You know, if you're just talking to us, it would be so much more enthralling and engaging.
There's a lot of information.
Yeah, I know. But you got that great visualization at the beginning, and you wrote this yourself, so you can be a little bit flexible about talking to us about this. And I know it always feels better when you have written something out and you know exactly how you're supposed to say it. The problem is that you don't say it that way.
That's why I wanted the thing so I didn't have to go up and down.
Yeah. I don't know that would have changed it. I think you would still be, limited behind the podium, and you'd be looking down a lot more. You'd look at the top of the podium instead of bringing it up. Because I think your face, that's another one of those things we're going to be talking about here in a second, is I think when you look up at us, you look like you're engaged, you look like you're interested in the topic, but then you look down at the topics again, you start looking at the notes again, and it's sort of like you disengage every time you look down. So we want you to stay engaged, and looking at the notes should be something that's much less frequent than it is here. The eye contact, same sort of thing. You're just reading so much more than you want to be doing at this point. I like the way that you turn the content into a speech. I like that there was a simplified structure from the details that you were talking about, so I thought you had the right idea there. Your explanations are pretty easy to follow, and usually there's a nice visualization there. There's not a huge amount of research in the presentation, but that's not something that was required for this particular assignment. So you're going to get away with a little bit there, but one of the compensations is supposed to be that you are, like I said, engaging us a little bit more. And I'm not sure that we quite get to that point. The volume of your voice is good. I think you need to use a little bit more range in your voice and have a little bit more inflection. There were some passages that I thought went really well, though. Picking them out is a little bit harder. When you watch the video back, I think you'll find, as you're listening to it, that sounds really solid, that's good. I'm looking at people, I've got enthusiasm in my voice, and then there'll be some long stretches where you don't have that kind of enthusiasm. It's just the kind of reading thing, and you want to be more the one way than the other. And I think right now that requires a couple of additional steps. Let's see. I don't have it on the evaluation rubric. I'm going to start doing that. I keep telling myself to do that because appearance is one of those things. Use of notes and appearance. I do have appearance here. The t-shirt and the shorts is a little bit informal for a presentation. If you're doing an impromptu speech, okay, you didn't know that you were going to be speaking, but you knew you were speaking today. Like I said, you don't have to doll up, but I do think you want to give a really, the kind of impression that you are on top of things, and dressing a little bit more formally probably does that. Helps, sell that idea. Okay, thank you.